Hello. In this lecture, we will be discussing about circles, and here we'll be discussing about the geometric properties of circles. So first, we'll be defining what a circle is so that in life, when you get to see a circle, you'll easily be able to identify, okay, this is a circle. Next, after that, we'll be talking about what a tangent is so that you can understand and recognize a tangent and also draw a tangent when required. Further, we will also be looking up a theorem regarding tangent properties of circles, and then using it we'll be doing a sum. So I'm sure this is going to strengthen your knowledge in tangent properties of circles, and then you will show a lot of confidence in tackling other sums that come your way. So let's get started and let us first understand what a circle is. So if we have the path traced by a movable point, right, in a plane such that its distance from another fixed point is always fixed, then the path traced out is a circle. So here let us consider this to be a circle, and here there is a movable point. Let us say we have the movable point to be, say, something like this, sometime here, or sometime probably here, but it is always moving in such a way so that its distance from this fixed point, let us consider that to be f, and let the movable point be, say, some p, is always fixed. The distance between the fixed point and the movable point is always fixed. So the path which is going to be traced out by this movable point is going to be a circle. Right now, children, I'm sure you people know this, that if we talk about the distance between the fixed point and the movable point, that is the radius. So if we talk about this distance, or if say we talk about this distance, then they are all going to be radius, and as such they have to be equal, right? And that is the reason we talk about the distance between the fixed point and the movable point always to be fixed. And this definition applies when the point is moving in a plane. What will happen if you make this point to be moving not in a plane but in space? Can anybody tell me? That will become a sphere, right? So it's just like a cricket ball or a football that you'll be having. That means it will be describing itself with the same properties and characteristics but in 3 dimensions, right? So now that we've understood what a circle is and what its definition is like, we will now be discussing about what a tangent can be. So let us consider that there be a straight line, and the speciality of the straight line is this, that it will be touching the circle just at a single point. So here as such we can talk about this to be a tangent where it is touching the circle, let's say at this point, which we can name to be, say, some A. So the point A is such that it is touching the circle at a single point, and such a straight line is known as a tangent, right? For that matter, for in-depth analysis in times to come, you will get to see in physics that when we talk about a straight line which actually intersects a path, for that matter here a circle, but the 2 points where it intersects are actually having an infinitesimally small distance among them, then you say that that straight line is a tangent, right? So we can consider here that it's just like another straight line, let's say like this, which has intersected the circle, right? But the distance between these 2 points, that is the point of intersection, that is the second point of intersection, is so very small that it is infinitesimally small, and as it is infinitesimally small, thus it can be considered to be just a single point, right? So ideally this is how this is looked up at. So at the moment, as this was a concept which at the moment we are not going to discuss, I just gave you an extension of your knowledge, so I'll just remove it at this time. Now, after we've understood what a tangent and what a circle is, let us now quickly look up the question. First, I'd like you people to try out, and after that I will be discussing the sum with you. Moreover, when you study, I want you to study in a specific format which will help you the best. That is, make sure this is not treated like a movie. this is a educational video which is teaching you something in mathematics, and you require to be serious about it. So sit with a fresh brain. That means you should have slept, then you should have got up and studying. Now with that, you have a fresh brain. So if you're feeling sleepy, right, take a bath or go and splash a little water on your eyes. Make sure that you're seated on a table and chair such that your spine is straight. That is not too tight but neutral, but it should be straight. So that makes you to concentrate the maximum on whatever is being taught. Next, make sure that you're sitting at a secluded place so that there is no disturbance, no brothers, sisters, mother, father, everybody moving around, right? And all the deviating devices like your television, the computer, your laptop, your mobile, etc. are all away from you so that they do not have the privilege to be able to disturb you. With this said, now let's get back to the sum, and I think if this sum is given to you for a little while, you will be able to try it and do it. And if you're able to do it, do write in comments that you've been able to do it before I discussed it, and I'm sure I'm going to be very happy. And something special that you've learned out of this class is also what I like you people to share, and some of your problems which you actually want me to share in my next lectures, that too you can write in comments, and I'm going to come to you and solve them out, right? So at this time I am giving you some 10 seconds to try, although if you're offline, what you can do is you can take a longer duration and you can pause the video, say for some 4-5 minutes, and you can give the sum a longer try. Right, so here children is the end of the time that I could have given you. Now let us discuss the proof of this theorem. Now here the theorem which has been given to you is prove that the lengths of the tangents drawn from an external point to a circle are equal. So in order to do that, we actually require to make a circle, right? And that circle should be having two sides of a triangle such that they are touching to the circle, right? Okay, so here let's make another figure. Let's say now that we have two straight lines and we also require a circle. So let us now consider that we have a circle, say something like this, right? And now we'll be drawing two straight lines, right, which are touching the circle, right? So one of the straight lines that can be drawn is, say, something like this, right? And the other straight line similarly can be drawn something like this. So as you see that both of these straight lines are such that they are touching the circle at a single point, and let us call these points of tangencies to be, say, some A and B, right? And let us call this external point to be, say, some point P. Now what we've got to show is we've got to show that the length of PA is equal to the length of PB, right? Now what we're going to do is we can draw a straight line which is the joint of the center of the circle with the point of tangency. So if this be the center of the circle, so from here if you draw a straight line to the point of tangency or to the point of contact, then what will happen is we will have an angle of 90 degrees made here. And similarly, if you talk about drawing another straight line from the center of the circle to the point of tangency, then that can be drawn, say, something like this. That is from here, which is the center of the circle, to the point of tangency, that is here. Now here as such, we know that the angle between the tangent and the radius at the point of tangency is going to be 90 degrees, or in other words, the tangent is perpendicular to the radius at the point of tangency. As such, both of these angles will be 90. Now you can draw another straight line which is the joint of the center of the circle to the external point, and if you do so, you will have had made two triangles, and as you can see, both of these are right angle triangles. Now, to be able to prove that both of these triangles are congruent, you will be using the RHS postulate. Now for that, you have one angle to be 90, thus one thing is proved. Now, as this straight line, which is the joint of the center of the circle, which can be considered to be, say, some C to the external point P, is a straight line which is common to both these triangles. And further, you also have these two straight lines to be equal because both of these are radii of the circle, right? And as such, here you can say that both of these triangles are congruent by RHS, that is right angle, hypotenuse, and side, right? And as both of these triangles are congruent by RHS, thus you can say that if you talk about these two lengths which had to be proved to be equal, they will also be equal because they, by CPCT, that is congruent parts of congruent triangles, are also going to be equal, right? So here thus we will write this now, not just orally discuss, but write it in the form of statements and reasons as you require to do it in your examination. So on the left hand side, children, you require to write statements as to what you did, and on the right hand side you require to do write here reasons, that is why you did this. So now this is what we're going to do. First is we'll talk about the first statement. So what was the first statement? It was this, that we first had some construction done, right? That you can write about the construction that you've done. Now further here you will say that if you talk about the angle which CA has with AP, that is going to be 90, right? So you will say that angle CAP is equal to angle CBP is equal to 90. Angle CAP, right, is equal to angle CBP, right, and both are 90 degrees. And here you will write the theorem why this is, that is the angle between the tangent and radius at the point of tangency, right, is how much? 90 degrees, right? So this is the reason why we will say that this angle is 90. Now the next thing that we can do is, if you talk about this triangle, children, we find that we had one straight line which was common, that is you can talk about CP, right? So you will say CP is equal to CP because it is common to both the triangles. So this is going to be the second point, right? You will say that CP is equal to CP, and here you will say that common to triangles. Which of the two triangles? One is ACP and the second is CBP. ACP is one triangle and the other is CBP, right? So in both of these triangles we have CP to be equal to CP. Being common, they will be said to be equal. Now the third is the radii, right? That is CA is equal to CB. This is the third thing. Now here we're going to write the reason that both are radii. right? And as such, now what you can say is, here when we are talking about two triangles that were one triangle being ACP and the other triangle being CBP, we have proved that both of these triangles are such that they are congruent by RHS. So in point number 4, you will say that triangle ACP is congruent, this is a sign of congruency, to triangle CBP, and here you will write the reason to be what? The reason that they are congruent by RHS postulate. Now after you've written this, the next thing is this, that we now are going to talk about that thing which we had to prove. That is, we had to prove that the lengths of the tangent drawn from an external point to the circle are equal, and thus you will say here that PA is equal to PB, right? This will be point number 5, that is PA is going to be equal to PB, and here you will write the reason to be what? CPCTC, that is congruent parts of congruent triangles, which are the two triangles that we have just proved to be congruent, that is triangle ACP and triangle CBP. Now that we proved this, so now we move over to the second part, right? That is, we now have been given a triangle, and in this triangle, using this result that we've just found out, we've got to find out the length of BC, right? So this length has to be found out, the length of BC. We've been given this, that the length of AB is 10, right? The length of AQ is 7, and the length of CQ has been given to us to be 5, or have been properly marked in this figure. So as you know that the length of a tangent drawn from an external point to a circle will be equal, so as such this length is going to be equal to this length, and thus here you can say that if one length is 7, the other length is also going to be 7, so both of these are going to be 7 in lengths. Now next, if this is 7, that is AR is 7, obviously the rest, that is RB, is going to be 3. So if this length is 3, because length of tangents from an external point, that is B, to a circle that is up to R and up to P are going to be equal, so this length also is going to be equal to 3. And next, now we are left out with the last one. So here we have the bit of information, that is CQ is equal to 5. So C being an external point, the length of the tangent drawn from C to Q or to P are going to be both equal. As such, this length is going to be 5, and thus the sum of both of these lengths is equal to 8, which is your final answer, that is the length of BC. Okay. Now, having found all of this, we will now have to write this in the form of statements and reasons. So what is going to be the first statement? It is going to be what you did first, that is, you will say that AQ will be equal to AR is equal to 7, right? Now for the second part, we now have here, first point is AQ is equal to AR, and here you will say that they are lengths of tangent from the external point A, right? As such, both are going to be 7 centimeter in length. Next, children, we will now talk about the rest of the length, that is BR, and it will become equal to 3. Now you will say that for point number 2, you now have BR, which is equal to 3, and as such BP is also going to become equal to 3, right? So first you'll talk about BR, BR is equal to 3 centimeter, right? You will say that AR plus BR is equal to 10, and here in brackets you will say that this has been given to you, right? Then you will talk about the third point where you will say that BR is going to be equal to the other length, that is BP, and it is also going to become equal to 3 centimeter, and here you will have to repeat the theorem that you wrote earlier, that is length of tangent or tangents from an external point that is the point B now in this case is equal. Here it was left out to be written is equal, and that we'll write here, right? So the lengths of the tangent are equal in both of these cases, and then we'll shift our focus to the next part where now we'll talk about the rest. So here now we have CQ, which has been given to us to be 5, so we will say that CP will also be 5. So CQ is equal to CP, and that will become equal to 5 centimeter. And again here you will say the same, that is length of tangent from external point. Which point? C. C to circle are equal, right? And that is the reason why both of these are equal. Now you'll talk about point number 5, where now you will say that if you add up both of these lengths, that is one length is BP and the other is PC, so you will say that BP plus PC is equal to BC is equal to 8 centimeter, right? And here I'll rather take it to the next line like this, right? I have this privilege, you can't do this, right? Okay, so this length is equal to how much? This is equal to 8 centimeter. Now you will say that, why have you been able to do this? You will say that by above, right? And thus this is the answer that you would require to bring, that is what is the length of BC. The length of BC is equal to 8 centimeter. So this is the second part. So children, all of this I've just quickly discussed. If there is any doubt at any point of time, right, I'll make sure that all of that gets removed. Moreover, if you have any doubt at the time of second explanation, all those children who are live, they can raise their hands, right, and they can ask their doubts. Okay, so children, here in the question we've been given that prove that the lengths of the tangents drawn from an external point to a circle are equal. So you have to prove that if there be an external point like the point P, then if tangents are drawn to it, only two can be drawn and both of the tangents will be equal in length, right? So here, in order to prove this, first what we do is we make such sort of a figure, right? And after making this figure, the first thing that we can do is we can join the center of the circle to this external point P, right, and thus mark the beginning of making two triangles. Now when we drop a perpendicular from the center of the circle to the tangent, we know that that will be passing through the point of tangency, and as such the angle between the tangent and the radius at the point of tangency is 90, even in the second point where again a tangent is passing through, right? As such, we now have two right angle triangles. So the first thing is done, that is the right angle is equal to the right angle, the first statement, right? And here you'll be writing what the theorem is, that is the angle between the tangent and the radius at the point of tangency is 90. Now after this we come over to the second point, where we will now say that if you talk about CP, it's going to be equal to CP because both of these are equal, being identical, and they are actually common sides of the two triangles that we are talking about, right? Next, after that, we also talk about the third thing, that is the third sides, that is CA is equal to CB, and the reason for that is this, that both are radii and as such both are equal. Now as we have both of these triangles in which RHS postulate has been applied, and thus we can say that both of these triangles will be congruent by the RHS postulate. And as both of these triangles are congruent, thus you will say that PA is going to be equal to PB, that is the length of the tangents drawn from the external point to the circle. Why are they equal? That is because CP/CT, as both of these triangles have been proved to be congruent, right? Now children, having done this, next now we'll be talking about the second part where we actually have been given a sum, and using this theorem we've got to do the sum. So what is this sum? The sum is, using the above result, find BC in the triangle ABC. So we've been given a triangle ABC in which we've got to find out the length of this side of the triangle, which is BC. Right? Can anybody tell me from the knowledge of trigonometry what can BC be also said as? I even gave you the hint of trigonometry. No? Well, always remember that in trigonometry, when we have a triangle, the side which is opposite to a vertex is said to be named by the small letter of the vertex opposite to which it is. So the length BC will actually become small a, the length AC will be small b, and the length AB will be small c, right? Okay, so we require to find out the length of small a, that is of BC. Now we're going to use this theorem that we just proved, and here further we've been given that the circle is inscribed in the triangle, or we can say that the triangle is circumscribing the circle. And further here we've been given that the length of AB is 10, right? This complete length of the side of the triangle has been given to us. We've been given that AQ is equal to 7, right? So this length has been given to us to be 7, and further we also have been given that CQ is equal to 5, that is this length also has been given to us. Now next here what we do is, as we know that AQ is equal to 7, so obviously it will be equal to AR, as from an external point A the length of the tangents will be equal, and this children is going to be our first statement. So here we will say that AQ is equal to AR is equal to 7 centimeter, and again we'll write the theorem that length of tangents from an external point A is equal, right? And thus we can say that this length will become equal. And now next, as we've been given the length of AB to be 10, AR has been given to us to be 7, as such RB will become equal to 3 and BP will also become equal to 3, because again the point B will act like the external point from which tangents have been drawn, as such their lengths will be equal, right? So this is going to be the next statement, that is BR will be equal to BP, right? And here we will say that this is because again the same theorem, length of tangents drawn from an external point B to a circle will be equal, and before that we've calculated BR to be 3 centimeter because AR plus BR is 10. So if we talk about AR to be 7, obviously BR is to be 3 centimeter. Okay, now children, after this we talk about the last part, where as we have BP now to be equal to 3 and CQ which is equal to 5, so obviously CP will also become equal to 5 due to the same reason, that is a length of tangent drawn from an external point to a circle are equal. So as such, again writing this theorem, we will say that this length CP also becomes equal to 5, and thus if you talk about summing up both of these lengths, that is BP and PC, that makes it 8, and thus we can say the length of BC is equal to 8 centimeter. And how have you done it? That is just by the things that we had to do above. So is all of this clear to you people? Sure? That's good. Now children, if you've been here to the end of this lecture, I'm sure you must have understood everything and also must have liked it. That's why you are here with me for such a long duration of time. So do take one advantage, that is there is a link which is there in my bio. You'll also find it in the description. If you click on it, then you can join me in a live class, because at this time I am just giving you part of a lecture. The rest of the children who are there in the live class, they will get rest of the class, right? So to be able to get complete knowledge is something which is going to be very good for your development in mathematics. Moreover, here sparingly I'm doing some topic today, some topic at the other time in the YouTube channel. Moreover, when it is live, it is all in accordance with as it should be. That is everything of a topic taken care of in regular classes, right? So do join me live by just clicking on that link, and you'll get me coming over to you and seeing what your problem is. And after that, I'll put you into a live class where with other children you will enjoy the mirth of mathematics. Bye children, have a nice time.